x squared minus 3x minus 10 equals 0. And this is the transformed quadratic equation. Good day, learners. Today, I'm going to discuss equations transformable to quadratic equation. The general form of a quadratic equation is ax squared plus bx plus c equals 0. But there are equations that are called in disguise quadratic equations. These equations are not actually exactly quadratic, but can form quadratic equations. Examples are equations of higher degree, like x to the fourth minus 7x squared plus 12 equals 0. Another is equation with radicals, like x plus the square root of x plus 1 equals 1, and rational equations like 2 over x minus the quantity x plus 1 all over 5 equals negative 4/5. Now, let's see how are we going to transform these equations to quadratic. Let's start with equation of higher degree. X to the fourth minus 7x squared plus 12 equals 0 can be written as the quantity x squared squared minus 7 times x squared plus 12 equals 0. Here, x to the fourth is written as x squared squared applying the law of power, and 7x squared is written as 7 times x squared. Now, if we let u be equal to x, this equation will become u squared minus 7u plus 12 equals 0. Because we replace x squared with u, and therefore, this is the transformed quadratic equation. Now, since the equation is already transformed to quadratic equation, we can easily solve it. By factoring, we can get the quantity u minus 4 times the quantity u minus 3 equals 0. Now, equating each factor to 0 will result to u minus 4 equals 0, and that will give us u equals 4. And the other factor, u minus 3 equals 0, will give us u equals 3. Now, if u is equal to 4, then 4 is equal to x squared, or x squared is equal to 4. And applying extracting square root, we can find the root, which is positive negative 2. Now, if u is equal to 3, then 3 is equal to x squared, or x squared is equal to 3. Same thing we did, applying extracting square root, x is equal to positive negative square root of 3. Now, let's go to equation with radicals. X plus the square root of x plus 1 equals 1. Applying the addition property of equality, we're going to add negative x to both sides of the equation. This will give us x plus the square root of x plus 1 minus x equals 1 minus x. And of course, x and negative x on the left side will be canceled out. It will form square root of x plus 1 equals 1 minus x. Now, if we're going to square both sides of the equation, this will become x plus 1 equals 1 minus 2x plus x squared. This 1 minus 2x plus x squared is the product of this square of binomial. Now, we have 0 equals 1 minus 1 minus 2x minus x plus x squared. If we're going to arrange this in standard form, it will become x squared minus 3x equals 0. This is the transformed quadratic equation. Now, again, we can easily find the roots by simply factoring. Okay, we have the factors x times the quantity x minus 3 equals 0. And of course, equating each factor to 0, we have x equals 0 and x minus 3 equals 0, that x equals 3. So these are called the solutions of the equation. So this time, let's go to rational equation. So we have 2 over x minus the quantity x plus 1 all over 5 equals negative 4/5. So multiplying both sides of the equation by the LCD, this will give us 5 times 2 minus x times the quantity x plus 1 equals negative 4x. And simplifying this, we have 10 minus x squared minus x equals negative 4x. If you're going to arrange this into standard form, it will become x squared minus 3x minus 10 equals 0. And this is the transformed quadratic equation. So this time, try to solve the transformed quadratic equation and type your answer in the comment section. Thanks for listening and see you on my next video.